Welcome everybody. It's cold and grey here in Brighton in the south of England, but it's lovely and sunny up where Kate and Judy are in Scotland. And wherever you are, from lots of people from all over the world, thank you for coming along. I'm chairing today's seminar. I'm Jane Waite. I work at the Raspberry Pi Computing Education and Research Centre. I'm very excited to welcome you to our fifth seminar in our new series on K-5, that's primary computing education and research. In this series, we're focusing on computing education for these younger learners, that's children aged 5 to 11 years old. And together we're going to explore how research can help us to support teachers and their students in the teaching and learning of computing. It's my pleasure to introduce these two distinguished speakers. I'm going to start with Kate, who I've known for quite a while. She's an incredibly experienced and accomplished computing education researcher. She has such a wide range of experience, including about data science, which is what's going to be our topic for today. And Kate has, she's had such an important impact on the national computing curriculum in Scotland. She's written so many different comprehensive guides on teaching computing science for practitioners at all levels. And currently Kate is working on the Data Education in Schools project, where she's developing, well, I think it's really exciting, data science and data literacy resources for primary and secondary schools in Scotland. And I think they should be for Scotland, England, Ireland, Wales, and the rest of the world. So joining her is Judy Robertson, who's a professor of digital learning at the University of Edinburgh. And Judy is a leading authority on digital learning and the academic lead for the Data Education in Schools project. So we've just got to say a huge thank you to Judy, because I think it's an area that has been woefully underrepresented in both research and in resources. And Judy's been at the forefront of developing educational technology for use with children and teachers for over 2 decades. I know it's longer than that. And her work focuses on how technology can help to solve real-world problems in education and health. And in their talk, Kate and Judy will introduce the importance of data literacy in primary and early years education across different curricular areas. And they'll be showcasing various pedagogical approaches, and I'm assuming that's going to be digital and unplugged, but we'll be finding out, to teaching data science and introducing as well, I hope, fingers crossed, to a range of resources and ideas, including some of their really popular live lessons, which I think have been accessed by over 20,000 learners. So I'm excited, because I really do think data science is one of those areas that we've not really got a good grip on it, certainly for my curriculum that I'm familiar with. So I'm excited to learn from you guys. So over to Kate and Judy.
So Kate and I work at the University of Edinburgh, and we are going to talk to you about primary learners as data citizens today. And maybe this isn't really a term that you come across, maybe you're not sure what data literacy is, but I think as we explain it, you kind of realise, I call it something different within my country or my school system. So I'm going to tell you a little bit about what the project does, and a little bit about what data literacy is, and also the problem-solving cycle that we use to teach data literacy. And then Kate has got lots of resources and examples to share with you as well. So there's a bit of kind of theory to start with and a bit of practical knowledge as well. And what we do in our project, our remit is working with the schools in the southeast of Scotland and primary and secondary schools, learners aged 3 to 18. And we started off having a look to see where data literacy might be within the Scottish curriculum to start with. And we discovered that it's embedded everywhere, but it's nowhere explicitly referred to as data literacy. And that's good in a way, because it means within the very interdisciplinary way that primary schools are taught in Scotland, that teachers can find ways to include it in lots of projects. We've also got some teaching materials for learners, which Kate will tell you a little bit about. And we do professional learning workshops for teachers as well. And a lot of those are face-to-face, but sometimes we have people join us online. So if you're keen to do that, you can get in touch at the end as well. Let's think about, first of all, what data literacy is. The definition which we use comes from Anneke Wolff, and it's the idea that data literacy is problem solving with data. It's the ability to ask questions and then to collect and analyze data which helps you to answer those questions. But it's also about interpretation of your analysis results. And really importantly, there's a set of communication skills as well to let you communicate what you've found out about the data and maybe persuade people that they should take some kind of action or change things as a result of the data that you've collected. And mostly within our project, when we're talking about data literacy, we're talking on how people analyze data. We're interested in machine learning as well, because we're nerds, and that's more about what machines do with data. But for mostly, when we talk about it, we're talking about the sorts of skills that children would use themselves when they're doing analysis. Now, our project has various sister projects within the southeast of Scotland, which are about working with older learners. So maybe people at further education colleges or universities, or people in employment. And there the focus is on learning data science skills because there are good jobs there and there's a skill shortage. And of course, there's part of what we do is about that as well. We've worked on a qualification with the Scottish Qualifications Authority on data science. But for us, it's more than just getting a job or using it in a job. It's about the set of skills that you need as a citizen to thrive in the kind of world that we live in just now. And that might be giving you the skills to find meaning in data, or it might help you to understand the kind of personal data which your devices like your phone and your Fitbit and your web accounts, those kind of the data which those devices collect about you, and knowing how comfortable you feel and how private you want that data to be. It's also about being a critical consumer of data, so knowing how to spot red flags in data that's a bit fishy or newspaper headlines that are a bit dodgy. And it increasingly for us, it's about the idea of activism, that if you can use data to construct arguments, to give evidence for your point of view, then you can use it to change the world. And the biggest example, I suppose, the most pressing example that young people are particularly concerned about is about climate change. And we've got some local area projects about that, which perhaps Kate will mention later. So for us here in Scotland, data literacy we know is already in the curriculum, and I suspect, I've seen a wide range of countries in the participants list, which is lovely. I suspect that probably you'll be able to find it in your own curriculum as well. You'll know it better than anyone else would. Within technologies, we've found core data literacy concepts, particularly within the computing curriculum. In numeracy and maths, if you look in probability and information handling, you'll find it there. In the English language curriculum, there's skills to do with spotting fake news and understanding how reliable sources might be, sources of evidence might be. Is there in the science curriculum with hypothesis testing and so on. And it's there in social studies if you look at things like politics or history or geography, that those subjects use data as sources as well. And within the Scottish curriculum at primary level particularly, teachers have got quite a lot of flexibility to weave these different areas into integrated projects in quite a good way. We've also looked at various ways that you can apply data skills across the curriculum. So once you've got the skills, you can use them to draw other curricular areas together. So for example, it might be something about food miles or physical activity. It might fit in with a sustainability topic you're doing. We've got some nice examples of art projects as well. So once you've developed those skills with your learners, you can use them in all kinds of different ways. Now, I made this Venn diagram because sometimes the teachers that we've worked with are not quite sure how data literacy is a term, how that might fit with digital literacy, which is maybe a more familiar term for some of the teachers that we've worked with. And computational thinking, I expect if you come to Raspberry Pi seminars, that's something you already know quite a lot about, but how does that fit with data literacy? So this Venn diagram shows that they're actually quite closely related. And at the heart of that diagram would be an example where all of those three things come together. So for example, if you've used devices like microbits, or I presume Raspberry Pis, for data handling, maybe you've got temperature sensors, maybe your kids are writing programs to get the data off of temperature sensors, that would count as digital and data literacy and computational thinking. But then if you look at the intersection between data literacy and computational thinking, That might be in structuring information. So within computational thinking, that could be structuring information by type and attribute in a database. But for data literacy, it could be making sure that you're collecting data of the right sort of categories, whether you're expecting a number or categorical data when you're collecting. And there's the intersection of data literacy and digital literacy. That's things like spotting misinformation or disinformation. It might be using software to make graphs. It might be understanding your data privacy settings. So there's quite a different range of skills, and you can come at it in different directions. Now, the way that we like to approach data literacy is through an inquiry-based approach, the idea that you can use data to solve problems. And so we like the PPDAC cycle, which you can see there, which I think originally came from New Zealand. So they do fantastic stuff with statistics education in New Zealand. And it's been adapted by various people ever since. And with that, you kind of go through this problem-solving cycle where you identify a problem that you want to solve or a question that you want to ask. And you go through the stages of planning, collecting data, analysing the data, and then drawing conclusions. And although it looks like just one cycle, inevitably you'll find that you might go back and forth between stages, or you might reach the end and discover that you've got more questions that you really want to answer. So it's quite a flexible thing. And the whole thing really is based around learners' curiosity. And if you work with primary school learners, you know that they have boundless curiosity. And what I like about this is it's a way to kind of harness that, but teach them a bunch of skills which are related to data at the same time. So we'll start and we'll go through the different stages of the PPDAC cycle. And then Kate has got some examples which will give you more information about that, with kind of ground it for you a little bit. So the problem stage is where you're identifying with your learners what it is that the project is going to be about. And sometimes this is because the learners have got burning curiosity and really want to know something. Maybe they've done an experiment in science, or maybe they've just been wondering about something and they have questions. The kind of questions that you might be trying to model is I wonder, or what do you wonder, or what do you want to find out? How can we find out what's going on? This kind of thing. And it sometimes happens that instead of the learners coming up with a question just off the cuff, that they might have a claim that they see in a video or a newspaper or online, and they're not sure whether it's true or not. And here you can get them to bring in their kind of detective skills to think about, well, how much should we trust this information? And does it fit with things we already know? And would that be a fair comparison, or could there be bias here? And these sorts of questions, if you see a headline which looks fishy, you can train your learners into routinely thinking this sort of thing. And if they get interested enough in it, maybe they want to move to the next stage where they would plan out how they could investigate whether this claim is true or not. This might be ringing bells for you if you're a class teacher. Maybe you already do this, but you just call it something slightly different. An example that we have here from one of our primary schools, Roslyn Primary School in Midlothian, they got very interested in how they could improve their health in the class, and they wanted to use their data literacy skills to see if they could improve them. So here, the girl has got a graph where they've been counting the sorts of exercises they've been doing in their gym class, but they also did stuff with healthy eating and sleep and so on. And they were just trying to track whether they would feel better, whether they'd be healthy after making various changes. So they used their data skills to do that. The next stage is the plan stage. And here, I suppose you're using your skills as a teacher to kind of think in advance, think through what question they're trying to answer and work out whether it's likely to be feasible with the amount of time you've got and the amount of resources you have to spend on it as well. So you're trying to guide them. On one hand, you want them to be able to create their own plans because that's exciting and it helps them feed off their curiosity. On the other hand, you want to make sure that it's going to work and they're going to get some kind of an answer that makes sense at the end. But you do this every day in your practice anyway. It's just that maybe you need a little bit of experience in seeing how these data projects sometimes play out. So the kind of things that learners might be thinking about here, and it will depend on the stage of the learners and how experienced they are, is whether you want them to collect their own data from scratch, like, do they want to run a survey? Do they want to count things within the school? Or maybe for more experienced learners, is there an existing data set which they could use, which already has a lot of answers? And the advantage of using an existing data set would be that they can be very large. They could cover hundreds or thousands of people. They could be national data sets. And then the question, the children can have more general answers. So there's various questions that you can ask. You can prompt the learners to be thinking about how are they going to gather the data, who are they going to collect it from, are there any possible ways that you would expect to get different results on different days, or are there other things you need to think about in how the data is collected. The next stage in the PPDAC cycle is the data stage, and that's really working with the data once you've collected it. And even if you're working with children in the early years in nursery school, they don't have to be working with, giant spreadsheets or databases. They can be working with small collections of real world objects like toys, and they can still be learning the kinds of skills that they're going to need later on, knowing how to sort data, how to organize data. And maybe this is the kind of thing that you do with unplugged activities with computational thinking anyway. Maybe it's you've got your Lego box and you're sorting the bricks by colour, or maybe you decide you're going to sort them by size instead. Maybe you're sorting objects into different sorts of toys, like cuddly toys or plastic toys and so on. So you're really just using very playful kind of things that you might do in the early years anyway, but you're kind of adding a data layer on top of it. And for more experienced learners who maybe have kind of grasped the stage of using tangible physical objects, and we've kind of moved beyond that, if they're using pre-existing data, then you're thinking about whether the data set that they've found is likely to be reliable, who collected the data, what range of values you might expect the data to take, what units of measurements were used. And as I mentioned before, if you're trying to sort out the data, that can actually be a very physical process as well. We've got the example here of a learner who I think she's been sorting out the food waste after lunch to try and think about plastics and cardboards and so on. And she's sorting by the material that the lunch waste was made of. And so that's a very easy to grasp kind of activity. And when you get onto the analysis stage of the PPDAC cycle, it's not that we're expecting primary school children to be able to do complex and fancy statistics, but our job at primary school level rather is to try and give them an intuitive grasp of what data looks like and how to make sense of it from graphs and tables to get an intuitive understanding of it, so that that's firm and solid by the time they come to their statistics lessons, maybe later in high school or in further education. And here, depending on the age of the learner, maybe you've covered things about mean, median, and mode or spread and variance, but maybe you haven't, but you can still get these concepts across. So for example, you might ask, what is the most common value in this category? Or you might ask, what's the biggest or the smallest value in our data set? So if you have all the heights of the children in the class, then you can say, well, who's the tallest person? How high is the smallest person? And crucially, one of the big questions that comes up a lot in data is, what's the difference between the largest and the smallest value? So that's a kind of measure of the variance. And even if you haven't learned how to use a ruler and do measurements yet, you can still say this is the difference between the biggest and the smallest. And you're still thinking about the concepts, even if you haven't actually got onto the measurements yet. Now, we're big into graphs. Kate and I love a good graph. And there's lots of fun activities that we've got to do with this. But just thinking about the sorts of concepts that we want to get across with graphs, if you start at the early years, you might be starting again from these very tangible objects. So number one there is just some leaves, which I took a photo of in the autumn this year. And if you're trying to work out how many leaves you've got of different colours, then you might move from the actual objects themselves to a picture representation of those objects. So you can see in picture 2 there, you've got a yellow leaf picture to represent the yellow leaf, and same for the other colours, but they're labelled now and there's a bit of structure with the grid. So that's getting across the idea that objects can be represented by pictures. And then as we move across to 3 there on the diagram, then maybe instead of the pictures themselves, you've got a dot to represent each object, or a tally mark. Maybe later, as you would do in early maths, you turn that into a frequency table with the numbers representing how many. And if you merge all your dots in a dot plot together, then you get a bar graph. And then maybe once the children understand fractions, you can get into pie charts. But what you're trying to do all the time is making sure that the learners are secure as they make the step between these more abstract, increasingly abstract representations. It's worth saying as well that there are so many really cool graphs now, data visualizations and infographics, which are far more exciting than the kind of graphs of packets of crisps, which I had to do when I looked at my maths textbook in primary school. And kids love them, so it's worth getting out some of the really fun graphs as well to look at. And the kinds of questions that you might be asking here, or the kind of cues you'd be giving your learners would be, what do you notice? What do you wonder? What about the shape of the graph? Can you see a pattern here? And just cueing them into these sorts of questions every time that they look at a graph. Just as some examples there, these are both about kind of world cultures. One's about a survey of languages spoken at home. And the other, I think, is from secondary school learners, where the children's families used to live, I think. And that's quite a nice example of how you can annotate a map with data, which isn't something that would be traditionally in a textbook, but is increasingly common. And then the last stage within the PPDAC cycle is the conclusions stage. And this is the bit where you're thinking back to the first problem stage. You're thinking, well, what question was it that I wanted to answer? And what are the answers? What did we find out? And also, what was surprising about it? Should we trust the results? Like, do we know we collected the data in a slightly imperfect way? Is there something that we could improve for next time? How should we tell people in our community about what we discovered? Do we need to try and persuade somebody to act based on what we found out? Because really, if you've gone to all the trouble of collecting new data, you have new knowledge and you should share it. Maybe it's going to make a difference to somebody in your community. And of course, maybe now you have even more questions and you need to go around the cycle again. This is an example from Roslin Primary School again, with their healthiness project. And here they have some data about the kind of food that people have as snacks within their school. And as a result of that, they decided that they wanted to try offering a healthy tuck shop instead of the normal tuck shop, to see if they could try and encourage people to have more fruit and vegetables or healthy snacks. Not sure what they're making in that. Maybe they're making soup or something like that. I haven't checked in.
Coleslaw, maybe?
Coleslaw, yeah, could be. I don't think anyone's going to eat raw turnip though as a snack. So that school, I think, has really got the idea of making changes based on what we find out with their data. So I'm going to stop talking and pass over to Kate now. I've got some examples for you.
Yeah, so we've developed a set of prompt cards for learners that can be used to go through that PPDAC cycle, giving prompts and ideas for using data. So we've got a range of them. We've got a set on Lego, we've got a set on plastics, we've got a set on lost property, and we have a set on birds. These activities should be available very soon, in a few weeks' time. So that link goes to holding page, but once they're live, then they'll be available on that website. So for the bird cards, we're hoping that learners will be inspired to think about different questions they might have in their local area. So that might be the school playground, it might be a local park, but questions they might have about birds, about wildlife in their local area. It might be how many birds visit the school playground, or different types of birds that visit, or how much do they eat. So these are just prompts that that can prompt learners to kind of then think about a project they might want to solve. They might want to go and investigate individually or in teams. Data can absolutely be collaborative. So yeah, so this is the problem stage. For the plan stage, once learners have a question that they want to answer, a problem, then there's prompts of how they can plan out getting an answer to their question and what data they'll need to gather. So if learners want to know how often birds visit the school, how could they solve that problem? What would they need to watch? Would they need to watch out the windows and the whole day and be counting the birds they see? Or maybe they could measure how much bird seed's eaten on different days or in different locations to help them answer that question. For the data phase, learners will need to go out and gather that data and sort it. If learners are measuring, for example, the bird feed remaining in a couple of different bird feeders on the school grounds, maybe they could take measurements different times of day for a week, or maybe they could take a measurement every day for a term. It depends on what they feel is necessary, what they've decided to measure. For analysis, what we can do is look at what we notice and wonder, as Judy was saying earlier. So we can think about, are there patterns or shapes that we can spot? And what do those patterns tell us? So if the bird feeders will go from full to empty, but what happens in the middle? And why do we think that's happened? Why do we think those patterns have happened? And then for conclusions, we want to check we've answered the question. So check we answered the question and then communicate our answers, our findings. So what have we discovered? Perhaps we need to make changes. Maybe we need to move the locations of the bird feeders and try again. Or maybe we've got more questions and want to gather more data. So perhaps we need to point a webcam at the bird feeder so we can identify the types of birds that visit. If you'd like to use any of these bird cards or the plastics of lost property, they will be available soon, hopefully in a few weeks' time. As Judy was talking, we have a teach data guide for primary teachers that there's a draft available for you there. Again, it will be available very, very soon. We hope in a few weeks, actually. And so this guide is a sneak peek. Please don't share it any further, but it will be available on the same web link again. And the guide talks through the PPDAC cycle, how to teach data literacy across the curriculum. And there's a handy section at the end that goes through links to great resources that are available online and ideas of things that you can be doing. And part of the guide is an asking good questions poster. So it's a 2-page spread in the guide, but we have it available as a separate poster because we loved it so much. And so it's just helping learners think about how they can frame questions in a way that's measurable, that's achievable, that's quantifiable, in a way that supports them making an investigation, carrying out an investigation, and turns them into superheroes. Other resources that we have a set of, I think it's 11 short videos, 2 to 3 minute videos that are available for teachers on what is data, techniques for teaching data literacy, explaining the stages of the PPDAC cycle. They're suitable for secondary teachers as well as primary. So they're quite general in terms of age and stage, but they're very reassuring videos. They're not expecting high levels of knowledge. They're step-by-step guides, very short videos. So hopefully those would help for you wanting to get a step into this area. As Jane was mentioning, we have live lessons. So we worked with this company, Cyberskills Live, who'd been doing cybersecurity videos. And we've developed a set of data-related videos with them, of live lessons. So we have a Defend the Rhino lesson, which is using ML, machine learning. We have a Code Your Own Data Selfie, which is looking at personal data and encryption. And we have a Plug in the Numbers lesson we developed for COP, which is learners calculating energy from solar panels that they could put on the roof of their school. So classes log into the website And they carry out engaging activities while there's a live video broadcast that's shown to the class. And there's like YouTuber style presenters who explain the tasks, give background information, and do shout outs to schools and learners. Jane mentioned 20,000. We've actually over 28,000 plays since November 2020 from schools, colleges, universities, people all around the UK and all over the world, actually. The Rhino lesson was our first one. We wanted to do something exciting that you wouldn't expect when you're coming to a lesson on data science. And so we invited learners to join our data science team to help us stop a gang of rhino poachers. We showed them how to use data science skills to analyse the security camera data from across a national park in South Africa. And it's based on real life case study with conservationists and technologists in South Africa that are using artificial intelligence and the Internet of Things to help save endangered wildlife. And so we designed the lesson so that no previous technical knowledge was needed, no data science skills were required, and all the instructions were built into the activities. And the kids have a lot of fun on them as well. Speaking of fun, we also have a set of escape rooms. So we have a set of themed escape rooms based on this motley gang of villains who are the Vikings. They're high-tech Viking villains who are trying to take over the world, and you as an agent of data have to stop them. So it's a set of downloadable data-themed escape room puzzles that can be downloaded. Again, that link is a holding page. It will be live, hopefully, again by the summer. We've got the graphic designer working like crazy trying to finish them off for us. And all good villains have pets. Evil villains have to have evil pets as well. So we have a set of pets as well. But the activities, the escape rooms are designed to give a sense of escapism, like a field trip, but without the hassle of transportation and paperwork. So you are an agent of data, the defense against temporal attacks, and you must stop the villains from building a secret lair, from sending information into the past using their information time machine, so that they're trying to raise money for their evil schemes. And you also have to figure out the secret code for your base when you accidentally lock yourself into the base, all using graphs and charts and logic to solve the puzzles and clues. So for example, this activity, the agents of data must work out where their secret layer is based on clues. So we know that the Viking villains are expanding an old existing nuclear bunker, so they have a data set for that. It's located near a wind farm, so we give the learners a data set for that. The Vikings want to steal the free electricity. It's near an existing data center because they want to hack into the internet and cause chaos, and using a transatlantic undersea internet fiber cable. So the learners find out all about these things as well, but they're using these data sets to map the information and narrow the possibilities down. Our Viking villains are pretty environmentally conscious. They want to take over the world, but they want it to be in good state when they take it over. We've also got a set of teachers working with us doing Internet of Things resources and looking at data from sensors in their own schools. So that's being installed across Southeast Scotland. But learners have been using this in really interesting ways. So for example, learners in Roslin Primary School have investigated the volcanic eruption in Tonga, which showed up on their school's IoT sensors as a pressure wave. And we put them in touch with a volcanologist from the university who was actually working on the site in Ecuador at the time, who answered their questions, but also confirmed their findings and showed them that the measurements and readings that they'd taken and the calculations they'd done were actually pretty accurate compared to what the volcanologists had been measuring and calculating. So these are real world connections, engaging contexts for learners, and it brings the importance of data and learning about data to life. As well as our resources, we've been showcasing a lot of our resources, but there are lots of fantastic resources available. Some are in the book, the Teacher's Data Literacy Guide, but also there's an incredible number of books that are available that are great for kickstarting discussions about data. We had a secondary maths teacher talking about this IF book that's first on the list here. And the maths teacher kind of thought, oh, a skinny little book. And he came back and he was just raving for about 5 minutes to all the other teachers about it. And just going, and I've done this and I've done that. And like he'd used, I think, this book with 3 different year groups in secondary school and had like 20 different engaging lessons just from a skinny little guide. And I would never have got this from a textbook. So sometimes it's useful to try different things. And there's some fantastic, lovely books that are so well designed. I think that is us for resources. Our next steps for you, suggested next steps. So we've got the videos, so you can do a little bit of professional learning in your own time and watch the videos. We've got the handbook. We also have a mailing list. If you want to find out more about the professional learning we're running, about new resources we're launching, but also please do get in touch. We're always delighted to hear from people asking questions and wanting to know more about data. If you'd like to get in touch with either of us, the next slide has our contact details as well. So please do get in touch with us and chat with us about data. Cool.
I just want to kind of give him a big round of applause. I really think that's brilliant. It's just fulfilled all my dreams of what you're going to talk about. So it's brilliant. So thank you. Our next seminar, which I'm really excited about, is on the 6th of June, and it's from AIM, who is from the Marina Bears team in the States, where they do the so under 5 years old students, and she's coming along to talk about Scratch Junior projects and assessment and a 12-week coding curriculum for our very, very youngest of learners. I'm so excited to have someone from the Marina Bears team coming to talk to us. So we look forward to seeing you there. Thank you very much again to Judy and Kate for talking about data, thing that we all love. And I'll see you at the next one. Have a lovely evening, everybody, or afternoon or morning or whatever time it is, wherever you are.